Now in my last video, which was part 2 of my Marantz 2215B stereo receivers series, I forgot to include the midpoint voltage. I had wanted to talk a little bit about that. I had mentioned it, I think, originally in the first video, but I simply forgot to include it in the last video, so now I'm making a mini video about this. Now this receiver uses one power supply voltage. I believe it comes in from J706, and that supplies one channel, and then if you go downward it supplies the other channel, and that's a positive DC voltage of about 53 volts. Now that was back then. Nowadays your voltages are a little bit higher. Your line voltages are a little bit higher, and this will be reflected in this voltage here, which might be a little bit higher. Also, it depends upon whether you have a load attached to the stereo receiver or not. But for my purposes here, this really won't be that important. What I want to point out, as I had previously mentioned, is that, for example, here the line voltage should have been, or should be, 53 volts. And right here at the output of these, this is a transistor pair, basically a complementary pair. One's a NPN and one's a PNP. Right here you have a spot called the midpoint, and from there it goes to the speaker capacitor, and then it goes to the speakers. Of course, the capacitor, what that does is block DC. Now at this very point, basically the voltage, the DC voltage, should be about half of what you measure up here. So we're going to go ahead and do that now. Also, I'm going to show, for example, using an oscilloscope, what would happen if it isn't. That might throw you off sometime if your supply voltage is, for example, too low, or you have something wrong with one of your resistors here, and that throws off this, basically this voltage. Now here's the supply voltage. It's 48 volts DC, and as I just mentioned, it's lower now because I actually have a dummy load, a speaker load, basically attached to the amplifier. So then at this particular point right here, which I'm pointing at with the end of my pen, the voltage here should be then about 24 volts, around there. It's never exact. It's going to be like ballpark. What you don't want is, you don't want to have, like, say 16 volts or something like that. Then you know something is really off. And of course I have the meter clip attached to the fuse holder, which goes to the power amp, and that supplies the power amp with voltage here. And right below that, seems like these two fuses here are speaker fuses, and I've attached a scope probe to that so we can monitor things. Now I moved the test clip from the voltmeter. I moved it to the, basically to that midpoint, which I had marked on the schematic. It's actually attached to one of the pins of the speaker output capacitor now. And now we can go ahead and see if what I said was true. And lo and behold, the voltage is basically as it is. It's going to be about half of the supply voltage. So now what I'm going to do is bring down the line voltage, basically, and what that is going to do basically is going to drop also the supply voltage to the amp board, and of course, which means the midpoint voltage is also going to go down. And we're going to take a look at a sine wave. I'm going to turn the receiver all the way up, almost to clipping, and then I'll go ahead and I'll drop the voltage, basically I'll drop the midpoint voltage, and we can see what happens to that sine wave. Now here's the sine wave, and I haven't mentioned it yet, but this is your standard 1000 Hertz sine wave, and the stereo receiver, basically it's putting out 15 watts per channel, all of 15 watts per channel I might add, and let me go ahead now and drop the voltage. Basically, again, drop the line voltage, which drops the supply voltage, which drops the midpoint voltage. So we can take a, or rather keep an eye on the sine wave, see what happens as I drop the voltage. Nothing. Okay, now we can see something here on the bottom. Let me focus in closer. Right there, we can see how this is, where my finger's pointing to, that it's flattened out. So that's what happens if your midpoint voltage is too low. Sometimes you might have a problem like this and you think everything's okay, but you might forget to check that voltage, and therefore you might run into that problem. Of course, you could have a problem with your power supply, or you could have a problem with your resistors around a transistor. Now we'll take a quick look at the multimeter. I just want to see at what voltage did basically the clipping start when I dropped the midpoint voltage down. Now right now we're showing about 24 volts. Again, this is supposed to be about half of the supply voltage. Of course, when I crank this up now all the way, when I turn the volume all the way up, I have a load here hooked up. This voltage here should go down. So that's why you might get different voltages than on the schematic. It depends upon, well, what's your line voltage? Do you have the volume all the way up? Is there a load attached? Blah, blah, blah. So, and we can see now I've got the volume all the way up, and I'm putting out 15 watts per channel basically. And now I'm going to go ahead and turn the midpoint voltage down. I just want to see at what voltage did it start clipping. I'm going down, nothing happening on the scope right now. It's about 17 volts. So it took, but basically took that much of a drop to make the sine wave clipped basically. In fact, I can turn it up even more still, and I still get, no, clipping is about right over 18 volts. It's hard for me to see basically. So it really doesn't take that much at all. So now I'm going to try to explain what we saw on the scope. So I made a primitive graph, and you can see here the horizontal axis is time, the vertical axis is volts DC, and I made this all the way up to 50 volts. This is not the actual graph, say, for the receiver, for the Marantz receiver. This is just for demonstration purposes. And the green line here is the midpoint voltage. Again, the midpoint voltage would be the voltage that you see on the schematic. It is the voltage without a load, without a signal. And the orange here is the sine wave coming in. So now if the midpoint voltage is at the right spot, if it's not too low or not too high, if a sine wave comes in, and say it's a large sine wave, it's going to go ahead and go up and down, and it's, for example, it's not going to hit the ground down here 0 volts. And also, it's not going to hit the top here, say the input voltage, the power supply input voltage, say if that was 55 volts, we would still here be okay, because it's not hitting that high. Because once it does hit that high, it would be chopped off at the top. Now earlier I brought down the midpoint voltage, and that's what we looked at on the scope. And here's, for example, what happens if we bring it down too much, or it's too low. Now I've got it here, the midpoint voltage, I took it down to 17.5 volts here on my graph, instead of the 27 or 27.5 volts, which was on the other graph. And you can see what happens if we get a large signal. On the negative swing of the sine wave, it's going to hit 0 volts, and it can't go any deeper, so it's going to be chopped off, and you get that clipping. Now if we go to the positive half, it's still going to be okay, right? The same thing happens the other way. For example, if we move this midpoint voltage, if we took it, for example, all the way up to say 35 or 40 volts, it would be okay on the downward swing like that, right? But on the top, it would go ahead and be chopped off too, because it can't be higher than the supply voltage. Say if the supply voltage was 55 and this positive half wanted to swing all the way up to 60, it couldn't do it. It would be chopped off at 55, basically 55 volts, and then we would get this flat piece down here, either on the top or on the bottom. That's called, of course, distortion. That's clipping, for example. I hope this kind of like explains it a little bit.